All right, so 8.2. Of course, I should have changed the top part. We're not multiplying and dividing. Now we're adding and subtracting. So now we're switching to adding and subtracting. 8.1 was multiplying and dividing. 8.2 is adding and subtracting. So adding and subtracting gets a little bit more complicated because you have to deal with whether the denominators are the same or if they are different. So back in elementary school, if you were doing 4/9 plus 2/9, that's easy. Add them up, keep the denominator, you're good. If you were doing 5/18 minus 1/3, not so easy. You got to get the common denominator. You must have common denominators in order to add or subtract. Same rule applies here. Same rule applies when you're working with rational expressions that have variables. Your very first thing should be to check, do I have the same denominator? If I do, then I'm straight. If I don't, then I got some work to do. So we're going to start with the denominators being the same. We're going to start with the denominators being the same. And we're really going to start with a basic example, just to remind you how to go about doing the problem. So, 7/20 plus 9/20. If the denominators are the same, then you simply add or subtract, depending on the problem, what the problem is. So, the denominator is the same, keep the denominator, and add up the numerators. So 7 plus 9 is 16, and then you reduce it. So if the denominators are the same, simply add and reduce, or subtract and reduce. So example 2 is no different. The denominators are the same. Keep the denominator and subtract the numerators. So 16y over 5x. Now, don't freak out if nothing simplifies. If it doesn't simplify, if it doesn't reduce, then it doesn't reduce. That's okay. If it doesn't reduce, then it doesn't reduce. That's perfectly fine. Don't force it to happen. If it doesn't reduce, it doesn't reduce. Any questions, 1 or 2? All right, then we got a factoring problem in our midst. So we're dealing with polynomials, the same rule applies. Our denominator is the same. Keep the denominator. Since there's a plus sign in the middle, we're going to add our numerators. x squared plus 7x plus 6 over x squared minus 1. So, simplifying in this case equals factoring. Simplifying in this case equals factoring. Top part, MAF. Top part's MAF. The bottom part is different than 2 squares. So we got some things that can happen. X plus 1, those match. They drop. Anytime we can simplify something, we're going to simplify. Anytime we can simplify something, we're going to simplify. Anytime and twice on Sundays. So before we go to different denominators, any questions on working with the same denominator? If there's something to click, say something. Went through something too fast and you want me to re-clarify something? Say something. So these were the same denominator. Same denominator is pretty simple. When the denominators are different, that's when things start to get a little hairy. So let's go to different denominators. So as you can see, we start off small, work our way up. We probably won't get to all of these examples in class, so I'll make sure to record them so that you have them for your asynchronous day on Monday. So let's start real simple. Seven over 10 minus 3 over 8. Now, somebody is going to make this mistake. Oh, well, 7 minus 3 is 4. 10 minus 8 is 2. That's 2. I'm good to go. That is never how you subtract fractions. You need the denominator to be the same. Period. So, I've got 10 and I've got 8. What could I make the denominator? I need something that they share. I need to force the denominators to be the same. So what could I use? What number could I use? 40. 40. Let's use 40. So since I'm changing the denominator, I have to change the numerators too. So, since 10 times 4 will give me 40, I have to multiply 7 times 4. Since 8 times 5 gives me 40, I have to multiply the numerator times 5. What you do to the bottom, you must do to the top. No choice in there. What you do to the bottom, you must do to the top. Now denominator. Subtract in this case. 13 over 40. It's not hard, we just have to use that brain. Any questions with example 4? We wanted a basic example before we start working with variables. All right, so variables get a little bit tricky. So that's why I wanted to do a number example first. So here's our denominators. 8 and 12, x squared and x, y and y to the third. We need everything to match. We need them to match. So we need everything to match. Let's figure out what we can do. Let's start with the numbers. Let's start with the numbers. 8 and 12. So what could we do with 8 and 12? What denominator could we get so that they're the same? Just looking at 8 and 12. 24. So, to go from 8 to 24, we have to multiply times 3. So 3 times 3 would give us 9. To go from 12 to 24, we're going to multiply the top and the bottom by 2. We took care of the numbers. Now we have to do the variables. So you've got x squared and x. So which one is bigger, x squared or x? Which one's more? X squared or x? How many more? Which one has more x's? Squared. So we're going to leave x squared alone. What times x will give us x squared? So what times x will give us x squared? X. So we're going to take the second fraction and multiply it times x. So why would we do that? Because x times x is going to force x squared to come into the problem. But if you do it to the bottom, you're going to have to do it to the top. Any questions with what we did to the x? Because we're about to do the same thing to the y's. Any questions on what we did to the x? Because we're about to do the same thing to the y's. Let's do the same thing to the y's then. You have y and y to the third. Which one is more, y or y to the third? Y to the third. So we're going to leave y to the third alone. Go to the other fraction. What times y is going to give you y to the third? Y squared. So we're going to multiply the top and the bottom by y squared. Y squared times y is y to the third, and y squared goes to the top. Look at that, now the denominators are the same. Any questions? Example 5. Any questions? Example 5. So, let's finish off example 5. The denominators are now the same. So we leave that alone. And we add the numerators. But there's absolutely nothing that you can do with that. So, that's your final answer. There's nothing you can do with that. There's nothing you can do with that. Any questions with example 5? All right, so this is a good spot for me